All right, people, here we go. Toolkit number 29. I'm cranking through these, and you are too. Good job. All right, here we go. We're talking about rational functions here. These get really funky. Okay. We're going to start off with a parent function, this. Okay. So y equals 1 over x. It looks like this. A couple cool things about this. This gets closer and closer and closer to the y-intercept, but never gets there. Same thing down this way. This gets closer and closer to the x-axis and never ever gets there. It just gets closer and closer. Same thing here. Okay. You could think of this as like, in a way, like exponential growth, kind of, right? Where it gets closer and closer to or exponential decay, right? It's not exponential decay, but it's kind of like it in that it gets closer and closer and closer to like a zero value and never ever gets there. Okie dokies. So when we graph rational functions, we need to make sure that we include the asymptotes, the horizontal and the vertical. So this is a horizontal asymptote. This is a vertical asymptote. And when it's in just its parent function, right, they're both at 0. So y equals 0 and x equals 0. Y equals 0. X equals 0. And I know this seems backwards, right? Because it's the x-axis, but the equation of this line is y equals 0. And I know this is the y-axis, and it's kind of weird, but the equation of that line is x equals 0, because these are all the points where x equals 0. Y could be 4, but x is 0, 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 x is 0. Y is equal to 0 here. X is 1, but y is 0. X is 2, y is 0. X is 3, y is 0. Y is 0 all along this line. So we call it y equals 0. Okay. It does seem odd. I know. Okay. But go with it. All right. So here we go. If we have this form, let's go f of x equals a over x minus h plus k. Okay, what we're doing is we're taking this function right here and we're transforming it in the way we've transformed everything else all year long. Okay, so A is going to tell us if it's stretching or shrinking, and is it flipping? So if A is negative, we flip over the x-axis. We flip up and down. Okay. A is the vertical stretch factor, so that's stretching up and down. Okay, so if this is 2, instead of going through 1, 1, it's going to go through 1, 2. It's going to stretch out. Imagine stretching it this way and stretching it this way, what that would look like. Okay. H is our horizontal shift. Okay. So H in here, just like everything else we've done this year, the one that's connected with the X is going to be opposite land, right? It's going to be opposite the way that we think. So if you have 1 over X minus 3, right? We have plus 3 here. So that's a good example. This means we're actually going to the right by 3. Shift everything to the right by 3. Okay, so it's the opposite land. Okay, it ends up that if we shift everything to the right by 3, the asymptote also goes that way. So H will also be the vertical asymptote. So my vertical asymptote would be Y, oops, sorry. My, my horizontal asymptote, um, oh, sorry. This is right by 3, horizontal. Yeah, I'm good. I don't know what I'm saying. Move on, Mr. Reba. K is the vertical shift, so that's shifting up and down, right? Um, oh, sorry. H is a vertical asymptote. That's where I was. My bad. My bad. The vertical asymptote is shifting to the right by 3, right? So the vertical asymptote is going to be x equals 3, is my vertical asymptote. There it goes. That's where my train of thought was going. Sorry, it's been a long day. K is my vertical shift, right? So that's the adding at the end. So that's going to be up or down, right? It's going to go the way we think it goes, right? K is the horizontal asymptote and end behavior function, right? So it's the horizontal asymptote and what happens in the long run. What is it going to be approaching as we go further and further to the right and further to the left? Notice it's approaching this same line right here. Okie dokies. So if we had 1 over x plus 5, that means we are going up 5. So that means my horizontal asymptote is y equals 5. Okay, so that means this, if we move the whole parent function up, it includes the asymptotes. And the asymptotes are key because once you graph the asymptotes, you can graph the rational function, right? So here we go. Let's do this problem. Can you identify what A is? Yeah, A is equal to -2. That's going to tell us two things. It's going to flip, right? So it was like this, right? This is going to flip this way. This is going to flip this way. Okay. It's also going to stretch by 2 by a factor of 2. Cool. So we know that. All right, let's get our h and our k. My h is whatever makes this 0, right? So I'm looking at x plus 3 on the bottom. That means this is moving left by 3, which means the asymptote is going to go that way, right? So asymptote, this is my vertical asymptote. VA is going to be x equals -3. We're moving to the left by 3. So I'm going to draw that in. 1, 2, 3. Okay, and I could write down here something like this. Vertical asymptote x equals -3. All right, my horizontal asymptote, is going to be -2. Okay, so this means we're moving everything down by 2. Okay, which means my horizontal asymptote is going to be y equals -2. So y equals -2 is right here. Cool. All right. Now, usually it would be here and here, but we have flipped. So the one that was up here is now going to be down here. Okay, so I'm just going to real quickly draw it like that. And the one that was down here is flipping over the axis, so that's going to be up here. Okay, notice when I draw these, I'm making it look like it's getting closer and closer to the axis here and closer to the axis here. I'm not, or sorry, to the axis, closer and closer to the asymptote here, right? And closer to this asymptote here. Cool, cool. All right. If we talk domain and range, domain is all real except for where this asymptote is, right? So domain, I'm going to write it like this. X cannot be -3. How about range? Range, it goes forever down, it goes forever up. We see that with this and this, but it can't be -2. So y cannot be -2, right? There we go. All right, just throw that out there. Good job, people. That's it. That's it. We'll play with this in class. Yay.